Welcome to Miss Hammarlund's science class. Today we are going to be learning about the solar system.
Ooh, can I help out? I know a lot about the planets.
Sure, Jenny. We have a few things that we need to cover first, but I know you'll be a great help. Before we talk about the planets, why don't we talk about the solar nebular theory?
What the?
Don't worry, I'll explain. The solar nebular theory is a theory about the creation of our solar system. According to this theory, a large cloud of dust and gas was disturbed, most likely by a supernova. The resulting waves from the disturbance caused the cloud to squeeze and collapse. Gravity pulled the gas and dust together. Over time, the cloud grew hotter and denser in the center, with a cooler disk surrounding it. Over time, this disk became thinner and thinner. Particles stuck together and attracted other smaller particles, forming the planets. The hot center became the sun.
Alright, that makes sense, but you didn't mention the moon. Is there a different theory about how it got there?
You know, Jenny, I'm really glad you asked me that. A good scientist always asks questions. There actually is a theory about that. It's called the lunar impact theory. The lunar impact theory explains that a protoplanet the size of Mars slammed into Earth early in its history. The collision caused material to ricochet into space. Eventually, this material settled into orbit, which formed the moon. This theory would explain why the moon is so similar to Earth in its composition. It is also believed that the moon's gravity is the reason Earth has a tilt.
Yeah, that makes sense.
Oh, I have more to say about the moon. Did you know that how much of the moon we see from Earth depends on the moon's position in relation to the Earth and the sun? This is why there are moon phases. And did you know that one side of the moon has a thicker surface than the other side? Due to the heat from the early Earth and the fact that one side of the moon always faces Earth, the surface has thinned. Because of this, lava has made the surface even thinner on the light side back when the moon was pelted by asteroids in its early history. The dark side has many more craters and a thicker surface.
Miss Hammarlund, as awesome as that is, we don't have all day.
Yeah, you're right. Moving on. The center of our solar system is the sun. The sun is a main sequence star. It is powered by nuclear fusion, a process where atoms fuse together and release energy. This energy is called a photon. It takes millions of years before these photons make it to the surface. When the sun runs out of hydrogen in its core, it will become a red giant and eventually a white dwarf.
Nice. Can we please talk about the planets now?
Sure, that's where we were going with this. If you know so much, why don't you tell the class about Mercury and pull up a picture on my tablet?
Mercury is the planet closest to the sun. It is also the smallest of the 8 planets. It has no moons, an 88-day-long year, and it has a thin atmosphere. Like the other inner planets, Mercury is a terrestrial, or rock, planet.
Nice! Here, why don't we take turns, and I'll talk about Venus. Venus is the planet closest to Earth in terms of size and mass. It is also the planet closest to Earth in distance. Despite this, it has a scorchingly hot and toxic atmosphere, and is even hotter than Mercury. This is due to its thick atmosphere trapping heat. Venus does not have any moons, takes 224 days to complete its revolution around the sun, and it's the brightest planet in our solar system.
Earth is the place that we call home. Earth has liquid water, is the perfect distance away from the sun to support life, and it's only slightly larger than Venus. It's the perfect place to call home. Our planet has an orbital period, or year, of 365 days and the perfect atmosphere to support those like you and me.
Ah, Mars, the red planet. Mars' red coloring is a result of iron oxide covering the planet. It is the second smallest planet in the solar system. It is a terrestrial planet that has 2 moons that are believed to be asteroids that were caught in its orbit. Mars has a thin atmosphere and takes 687 days to complete one full revolution around the sun.
Jupiter is the first of the gas giants and the largest of all the planets. It takes about 11.8 years for Jupiter to complete one full revolution around the sun. There is a huge storm on this planet called the Great Red Spot, which has been raging for hundreds of years. This giant planet has 69 moons and a large atmosphere mostly composed of molecular hydrogen and helium. Saturn is known for its spectacular rings, made up of rocks and ice. It is the farthest planet from Earth that can be seen with the naked eye. Like Jupiter, Saturn is a Jovian planet. It has 62 moons, takes 29.45 years to complete one full revolution, and has an atmosphere made up of hydrogen and helium gases. Everyone seems to like Uranus for its name, and no, it is not pronounced Uranus. Uranus is tilted on its side. This is thought to be due to a massive impact in its early history. Uranus is a Jovian planet with methane in its atmosphere. There are other gases making up the planet and its atmosphere as well. Uranus has 27 moons and takes 84.3 years to complete one full revolution. And finally, we have Neptune. Neptune is very similar to Uranus in both size and composition. Neptune's atmosphere is made up of hydrogen, helium, and methane. The dark blue planet has 14 moons and an insanely long orbital period of 164.8 Earth years. This is just because it's so far away from the sun. And don't forget about Pluto. I mean, I know that it's a dwarf planet, but we can't just forget about it. Well, of course not. Pluto is one of the dwarf planets, a celestial body similar to a planet, but missing certain criteria to be classed as one. Pluto isn't even the only one of these in our solar system. There's also Makemake, Haumea, and Ares, located in the Kuiper Belt, and Ceres in the asteroid belt. Speaking of the asteroid belt, I heard someone say that the asteroids are super far apart, but they're always portrayed as being super close together, which is true. Asteroids in the asteroid belt are super far apart. In fact, if you were to stand on one asteroid, you wouldn't even be able to see any of the others. The asteroid belt is actually less dense than Earth's moon. The asteroids are rich in carbon and silicate, and it is believed that these rocks are the remnants of a planet that could not form due to Jupiter's gravity. This is so interesting. I love this class and I love being able to help out all the time. Well, I'm glad you feel that way because we're glad to have you. And there's the bell. Have an astronomical day, everyone.
Woo, you suck.